Welcome to today's session on information privacy, technology, and big data. In this lecture, we'll explore how the rapid growth of digital technologies and data analytics has created both opportunities and challenges in managing personal information. Our goal is to understand the scope of these challenges and examine strategies for protecting privacy in the age of big data. Let's begin by defining what we mean by information privacy. This concept refers to the rights and expectations individuals have regarding the collection, use, and sharing of their personal data. As digital systems become more integrated into our lives, the boundaries of privacy are constantly being tested. This session will explore how big data and technology intersect with privacy concerns, setting the stage for deeper analysis. The intersection of privacy and big data is a critical area of concern. Technological advancements have enabled organizations to collect vast amounts of personal data, ranging from demographics to behavioral patterns and health information. A 2012 New York Times report on Axiom Corporation revealed that data brokers maintain detailed profiles on hundreds of millions of individuals. This includes sensitive information such as political views, shopping habits, and even vacation preferences. These revelations highlight the urgent need to address privacy risks and develop mitigation strategies. Before we dive into privacy implications, it's important to understand the scale and nature of big data. The term refers to extremely large datasets that require advanced technologies for storage, processing, and analysis. Let's look at some statistics and definitions to grasp the magnitude of this phenomenon. Big data is growing at an unprecedented rate. Google processes over 24 petabytes of data daily, and YouTube users watch more than 6 billion hours of video each month. Twitter handles 32 billion searches monthly. In fact, 90% of the world's data was created in just the last 2 years. Gartner defines big data as high volume, high velocity, and high variety information assets that demand innovative processing. Technologies like NoSQL, MapReduce, and machine learning are used to analyze this data, which often includes personal information. This raises significant privacy concerns, especially when data is used to infer sensitive details about individuals. This visual illustrates the complexity and scale of data analytics. It serves as a transition into our next topic, the specific privacy concerns that arise from big data practices. With the scale of data collection in mind, let's examine the risks and harms associated with big data. These concerns are not hypothetical, they affect real people in tangible ways. From surveillance to profiling, the implications are far reaching. Big data can lead to serious privacy invasions. These include unauthorized access to private communications, tracking of individuals' locations, and public disclosure of inferred private facts. False conclusions drawn from data analytics can damage reputations and limit personal autonomy. Algorithmic discrimination is another major issue, where biased data leads to unfair treatment in employment, insurance, or pricing. Emotional distress, reputational harm, and even legal consequences can result. These risks underscore the need for strong privacy protections and ethical data practices. To better understand these risks, let's look at real-world scenarios where big data has been used in ways that compromise privacy. These examples demonstrate how everyday technologies can be repurposed for surveillance and profiling. Consider devices that detect radio stations in passing cars and sell that data to advertisers. License plate readers track vehicle movements. Machine learning algorithms are used to predict criminal behavior and gambling addictions. Retailers use WIFI tracking to recognize returning customers and optimize store layouts. Social media data is analyzed to detect suicidal thoughts or predict college dropouts. Even credit decisions are made using non-traditional data sources. These examples show how pervasive and invasive data collection has become. Consider devices that detect radio stations in passing cars and sell that data to advertisers. License plate readers track vehicle movements. Machine learning algorithms are used to predict criminal behavior and gambling addictions. Retailers use Wi-Fi tracking to recognize returning customers and optimize store layouts. Social media data is analyzed to detect suicidal thoughts or predict college dropouts. Even credit decisions are made using non-traditional data sources. These examples show how pervasive and invasive data collection has become. Data collection tools include cookies, IP addresses, search logs, email scanning, and social media monitoring. Research methods range from surveys and behavioral observations to A/B testing and microtargeting. The types of data collected are vast: demographics, opinions, geolocation, browsing history, health records, and more. These data are used for market analysis, consumer profiling, and predictive policing. The sheer volume and variety of data collected demand careful consideration of privacy implications. Data can be categorized into three main types: conventional, born digital, and sensor based. Each type contributes to a detailed profile of individuals, often without their explicit consent. Conventional data includes phone records, credit card transactions, and bank statements. Born digital data encompasses emails, text messages, device interactions, GPS data, and RFID tags. Sensor data includes biometric readings, surveillance footage, infrared imaging, and medical scans. These diverse sources create comprehensive profiles that can be used for both beneficial and harmful purposes. The privacy risks associated with such detailed data collection are significant. Once data is collected, it's analyzed using sophisticated techniques. These analytics can reveal patterns, predict behavior, and support decision making, but they also raise ethical questions. Big data analytics use classification, clustering, regression, association, and anomaly detection to extract insights. Data fusion merges multiple datasets for business intelligence. Image and speech recognition technologies enable facial recognition, biometric surveillance, and geolocation tracking. Social network analysis maps relationships and influences, even identifying terrorist networks. While these tools are powerful, they must be used responsibly to avoid infringing on privacy. Behind all this data processing is a robust infrastructure. Data centers and cloud platforms store and manage vast amounts of information. But infrastructure alone isn't enough. We need strategies to protect privacy. Privacy protection technologies include cybersecurity measures, encryption, identity-based and attribute-based, and anonymization techniques. Policies like notice and consent, data deletion, and non-retention are essential. Enhancing online privacy also involves phishing protection, strong passwords, safe use of public Wi-Fi, and webcam safety. These strategies help mitigate the risks associated with big data and ensure responsible data handling. As we conclude, let's reflect on the importance of ongoing dialogue about privacy. The challenges are evolving, and so must our responses. Safeguarding personal data requires continuous engagement from individuals, organizations, and policymakers. Ethical data use strategies must be developed and implemented. By understanding the tools and implications of data collection, we can create a more secure and respectful digital environment. Thank you for your attention and thoughtful participation in this important conversation.